So, once again, guys, don't forget every week, or not every week, every day I record during that direct instruction part so that if you need the extra support and need to go review major concepts, it's online. You just have to search my name on YouTube. First channel that pops up. Nice and easy. Now I'm going to talk about a couple of things. First things first, we're going to do the demonstrate our understanding analysis and some Q&A. Also time for you to just work in your small groups and ask questions to make sense of ideas. We're going to use lesson 4 from the book as a final review, and then we're going to start the next unit. Really quickly before I forget, which he informed me today, he prefers to go by Mr. Hobby. So this is Mr. Hobby from UA. He will be with us 3 days a week, is that right? 3 days a week from UA. He's entering his second to last placement. So he's got some experience, and I actually got to be a part of his interviews last fall? Last spring?
Last spring.
Last spring.
Yeah.
And for him to be admitted into the teacher education program, and I was really excited the way that he was talking about math and education. So he's going to be a great resource to have in the classroom. Make sure you talk with him, get to know him, ask questions, because again, he'll be a great resource. Today we're going to start with Mathematician Monday, and then some notes about justifying. Oh, that's during the demonstrated understanding. That's for later. So, I want to point out, or we're starting with the mathematician. This is Dr. James A.M. Alvarez. He is from Texas, of Mexican descent. So I wanted to point this out. One of the things that I'm trying to heavily hit with these Mathematicians Mondays is that anyone and everyone can be a mathematician. Like all of you can be that. And I want to support and encourage you to see people like yourself, outside yourself, who have pursued this. So, Dr. Alvarez, a couple of small details as background before I talk about why I really wanted to celebrate him today. So he was born in a place called Pamco, Texas. Literally that name was built off of the name of the company that everyone there worked for that basically built sewage pipes, I think. And so they literally called it a company community, right? So it's not, building sewage pipes is not a glorious thing. Not a lot of money there. He grew up in a 2-bedroom teacher's cottage, so his mom was a teacher in the town until they realized that a town of 200 people wasn't enough to sustain a school. And so they actually merged that school with another one. So obviously coming from a family without a lot there. So this guy's a little bit different than the last couple that I celebrated, because the last couple came from backgrounds that weren't necessarily the strongest with math. Dr. Alvarez found out very early that he was strong at math. Literally, by the time he said he started first grade, he was able to support and teach some of his mom's students in grades above him. So it's an unusual place to be going into first grade. But one of the things I want to point out is the school that he ended up going to was about 50 to 60% Hispanic. But only 16% were in the advanced group of students, right? So they had regular classes and advanced classes, much like we do. And so I always want to point out that we need to recognize injustices where they are, because how is it that 50 to 60% of the school is Hispanic, but only 16% are an advanced group? Are we saying that Hispanic students are not as capable as their white peers? And that's something that I want to push back on, and I want us to think about. Think about the school that you go into. Do you see similar issues there? But the point that I really want to emphasize is he literally dealt with heavy discrimination. His sister was literally told, even though she had top marks in all of her classes, hey, you won't be able to make it in these upper level maths, so you should take something lower. And that's a message that I never want a student to ever hear from me. I want you to always hear that you are capable. Doesn't matter what your background is, doesn't matter how much money you come from, it doesn't matter what your race is, you are capable of doing math and of being a mathematician. But there's another reason why I want to celebrate Dr. Alvarez. So, as I said, he was a pretty strong math student, right? Pretty successful, went to college, got a math degree, finished his undergrad in 3 years, and then he went to pursue his PhD almost immediately after it. And this is where I found his story compelling and interesting. in his PhD program, he had to take what's called a real analysis class. That probably does not mean anything to you. It's a really heavy deep dive into understanding calculus, and he struggled. And real analysis is an undergrad level course. And he then also jumped straight into his second semester of a math class called abstract algebra. And he was struggling there as well. And this guy who found himself consistently at the top of math really found himself struggling for the first time. But it's not because he wasn't smart, is what he eventually realized, and this is what I wanted to encourage you with when you struggle as well. He jumped into his second semester of abstract algebra without taking the first. So he was missing a lot of the foundation that all of his peers were. He had bad advising that caused him to miss out on a real analysis class. Thank you. Why don't you join the Kings for me? And so it wasn't that he wasn't capable, it wasn't that he wasn't intelligent enough, it was that he just had missing background, which really affected his ability to learn. But he still overcame that, he still got his PhD. And so I want to encourage you, in my class, I know there's going to be times when you have difficulties, there's going to be times when there's gaps, but that does not mean you're not capable. You're still capable. I'm going to be here to support you. You're going to have your peers to support you, and you're going to have all the resources you need. So let's keep on working on that. So he ended up pursuing or teaching an emerging scholars program to support students like himself that grew up in poverty, that grew up probably in a more discriminated environment. And so these are scholars who are coming from backgrounds that wouldn't have had certain types of success otherwise. And I want to just point out right here, his dissertation, I have no clue what that is. I've never studied percolation theory. I know a little bit about statistics, but not statistical physics and mathematics. But right here, again, he said problems in this theory are very simple to state, but extremely difficult to prove. The independence required to conduct my research and the intensity of the research process left me feeling very isolated. Math is tough at times, but you're not alone. You're not isolated, even if you feel that way. When you have a community around you that can support you and help you, it makes a huge, huge, huge difference. So let this be your mathematical community, because he found power and he found strength out of this eventually and ended up focusing on math education research. How do we teach math to support students? So an absolutely fantastic story. I can give you more information if you are just interested in learning about him, because really phenomenal life into the math ed world. So that is Dr. Alvarez. Thanks for letting me teach you about a mathematician. Leah's like, oh, that's really exciting. Thanks, Leah. I appreciate it. Or not. Anyways, all right, so moving on from there, content. Notes about justifying. One thing I want to point out is, why do I have you justify? So you got your demonstrate understandings back. You still need yours. Who else came in? Kennedy, you still need yours. All right, so let's look at these demonstrate your understandings really quickly. I just want to point out, thank you for turning that reflection. I just want to point out with these demonstrate your understandings, oh man, I forgot to put it into the slides. I'll have to do that for the future. But there are times when you can be off on your final answer, but you have the right reasoning. And so when you have the right reasoning, but you get a wrong final answer, and you show me how you got there, I can honor your reasoning, right? There's CE for clear evidence, but you can still make a procedural mistake within there. When you show your evidence for how you got to the point that you did, so a lot of you will notice feedback at different points. But if you just put an answer or don't put anything, can I give you feedback? Can I write anything to you to help you understand where you went wrong? So when I ask you to show me evidence, one, justifying is something I want you to do on every question, even when it's multiple choice. Okay? Because that reasoning is what matters. And once again, this is the very first unit. I assume you've never had anyone assess you like this ever in your life. Is that fair? But it's because I'm not just grading you, I'm giving you feedback to improve your understanding. So take this, learn it before the test. Because I told you before, I don't care about what your grade is as we're learning. I care about you learning it long term. So show me on your assessment tomorrow that you understand all these concepts better, and I will update your demonstrate and understanding grade for what level of mastery I see. Deal with that? Okay. Learn and grow and get better. Ask the questions you need to. What I'm about to talk about right now is focused on questions that or issues that I saw from across the class as a whole. But remember, I'm going to give you time to ask questions after this, or as we're going, but also to work on things to prepare for your test after we go over all this. So, notes about justifying. Oh yeah, forgot to put this in there. Always do it, right? Even if I don't say justify, you're always supposed to justify. Show me your evidence for why you're putting the answer that you are. Important for me and you, tells me how much you actually understand, and I can give you feedback, and learn from it and grow. It doesn't matter where you are initially, what matters is where you end up. That can even be after the final test, but I prefer us to get there before the test. Okay, one thing that a lot of us implied, but didn't actually state here. Guys, what are we using for number one? What are we supposed to be using here? Empirical rule. How many of you actually wrote empirical rule? Or wrote 68, 95, 99.7? A few of us, right? But not all of us. Jaden, I'm going to talk about the way you did it, because I do like the way Jaden did it. I will talk about the caution I give with that in a second. But guys, empirical rule. Right? Just writing this tells me you recognize that you can use the empirical rule. Now, why do we know we can use the empirical rule here? Because we're looking at what? A normal distribution, but there's one more detail that we want to notice. Can we always use the empirical rule with a normal distribution? No. What else has to be true? It's something to do with this right here. Has to be symmetrical, what? Doesn't have to start with 1, but remember, this is how many standard deviations? 1. So it has to be an integer number of standard deviations, right? Are we dealing with integer number of standard deviations? So empirical rule it is. By the way, you can make whatever notes you need to. I do have to recollect it and scan it, but I've already given you feedback, so write whatever notes you need to improve your understanding. But yeah, normal distribution and integer number of standard deviations. All right, I'm going to skip A for the sake of time. I'm going to focus on B, so do notice, boom. All right, so what's the first thing that I highly recommend you do here? Draw that graph, right? It's going to help. Now, what's right in the middle of that graph? It's 7 hours, or how many standard deviations? Okay, right? So notice I pair those ideas together. 7 hours or 0 standard deviations. Where am I going to go next to finish labeling this graph? Right. To the right, where? What's that? Remember, that point of inflection tells me 1 standard deviation, right? Brianna, what was the length of 1 standard deviation? Well, sorry, just the 1 standard deviation. Sorry, no. Just how long was 1 standard deviation? Which is how you got that 7.7, right? Guys, notice like the length of 1 standard deviation is 0.7 hours. I had students go from 7 to 8 to 9. 1 is not the length of the standard deviation here though. 7.7 is 1 standard deviation above. Right? For the next standard deviation, Bella, how long is the next, or how long is, what do I need to do to get to that next standard deviation? How long is 1 standard deviation? 0.7, so what do I need to do to get to that next value? Say it with what, that 0.7? Add, right? 7.7 plus 0.7 is 8.4. And I take my distance again. Notice how I'm literally just using my finger trying to keep roughly the same distance. And then same thing on the left-hand side. But instead of adding, what am I going to do over here? Subtract. All right. Based on the directions for part B, what do I want to shade? So 5.6 all the way up to, okay? Now, some of y'all did a method that 100% works. Finding the difference and kind of subtracting it out, but I'll point this out. If you remember, I like to deal with halves, right? Because if I look to the left of the mean, how much of that data is to the left? Half. How much to the right? Because that's symmetry. So right here, well, between -2 and 2 is what percent of my data, Jaden?
Was it 47.7?
All the way from -2 to 2. Right? Remember your empirical rule, 68, 95, 99.7. So what do I want to do if I just want the left half of that? It's just half, isn't it? Half of 95. That's all you had to do. 47.5. Right? I'm dealing with 2 standard deviations. On the right-hand side, I'm dealing with how many standard deviations? On the right-hand side? I'm always going all the way to 9.1. How far is it? What percent of data is between 3 below and 3 above? 99.7. So I need half of 99.7, which came out to be 49.85. Now I just got to put them together. Kyron, what do I do mathematically to put stuff together? I add them together, right? Now, please hear me clearly. Did some of you do a different method that 100% worked? Yes, totally valid. But that might be an easier way. And notice, I didn't do a ton of writing, but am I showing work that can be evidence for why the percent of laptop computers is between 5.6 hours, or with battery life between 5.6 hours and 9.1 hours is, what is that, 97.35%? Like, is that evidence for how I got there? Yes, Mr. Kim? Yeah, 100%, right, that's evidence. That's justification. I didn't just put an answer, I put a claim, and I showed evidence of how I got that answer. What are your questions about using that empirical rule? And to honor some of y'all's thinking, some people noticed from 3 below to 3 above was at 99.7, and then they found this and took it away, right? Because you take away what you don't want. That's a totally valid option as well. Yes, ma'am.
You said they found it. How did they find it?
So, if you know that this whole thing is 99.7 and this is 95, then if you subtract them, you get both of these, right? So 99.7 minus 95 is 4.7, right? So between these two, I have 4.7%. So if I just want one of them, it's only half. And so this piece right here is 2.35%. So if you take your 99.7 and take away that 2.35, you also get 97.35. Okay. And Xander, does that make sense? Because that's what you tried to do, right? Yeah. And guys, please make sure you use a calculator, right? We don't want to get 2.7 when it's 4.7 just because we're not paying attention. Use those calculators. All right, last thing though, to support y'all, JD, you took a completely different approach, didn't you? What'd you do?
I used a normal CDF.
Hey guys, is this a normal distribution? If you are stuck on the empirical rule, could you use normal CDF to find the area under that curve? Yes. Now, the one word of caution I'm going to give you about that is, on the proficiency scale, you have to show me that you can use the empirical rule, right? So, Can you earn a lot of evidence for understanding using the normal CDF? 100%. But you cannot earn credit on the proficiency scale if you don't use the empirical rule at least once or twice. Does that make sense? So and the other thing I'll point out is, if I were doing this, and because I think you used a mean of 7 and a standard deviation of 0.7, one, draw your normal distribution out, and then use that normal CDF. And what would be your lower bound though? Remember, I'm going to recommend you use those z-scores, because that's what these are, z-scores. So lower bound of -2 and upper bound of 3, mean of 0, standard deviation of 1. That's what it would show up in as on the calculator. And you know what that's going to give you? Or at least really close. Now remember, that is the probability that one computer has a battery life between 5.6 and 9.1 hours. But again, the percent of all computers is this. By the way, could you check yourself quickly using the normal CDF on the test? Right, so I would use the empirical rule. It's quicker, it's faster. But if you were to say, hey, Mr. Kinney, I use my normal CDF to check myself, that's actually a really strong way to go from a CCC to a CCC plus if you want that extra little bit of credit there. Yes, Miles. Oh, you're not raising your hand? Oh, gotcha. All right. I'm going to give you all more time to practice with these things in a little bit, but what questions do you have up to here? Going once. Going twice. So remember, halves with those empirical rules is a great, great time. And don't forget, you also have check your understanding questions to work on as well. All right, number 2. I think I could be wrong on stating this, but I think everybody got number 2 right. Which of these is a normal distribution? D, right? But here's the thing, what should you say to tell me that that's approximately normal? It's symmetrical and unimodal, right? You guys say it's symmetrical, it's unimodal, you can even say it's bell-shaped, but like if you want to show me clear evidence for why that you understand a normal distribution, what could you say here? So yeah, again, remember, if it's normal, it needs to be symmetrical and unimodal. What could you say here for why this one is not normal?
Not symmetrical.
It's not symmetrical, but what's a more clear way we could say that? Something else we could add there that we know.
I forgot it's
Skewed right. That's why it's not normal. Why is this one not normal? It's bimodal. Why is this one not approximately normal?
the top.
Yeah, that top. It doesn't actually peak up there. If you were to actually look inside of here, you would not get 68% of your data between one standard deviation below and one above. And so because it doesn't have that normal one peak there. That's strong evidence that you understand if you talk about those things. Make what notes you need to, what questions you need to ask. Looks like a lot of us are feeling good on this one. Hopefully. Okay. This part with number 3, the interpreting and the explaining the meaning is what got most of us, more than anything else. But this question as a whole got us more than the other sections. So I'm going to spend a little bit more time here. Interpret the mean. Guys, if I'm asking for an interpretation, I'm asking for something in context and the core meaning of a mean. So what's the core meaning of a mean? It is the what? It is a measure of center. What type of measure of center? It starts with an A. Average, or the typical, right? When we talk about a mean, it's what we expect to see. This is the typical what? What's the context here?
Teachers, students, sorry for the interruption. At this time, we are going to have our lockdown training. At
Go to
this
the
time, we're
corner.
going to have our lockdown training. Students, teachers, the next 30 seconds. And,
Make sure
We have to
no one
train
can,
it
Elizabeth, can you see out the window at all?
have to have an actual lockdown. Student teachers, you all should be aware that any student or any teacher has the ability to call a lockdown at any given time if they see something that is out of the ordinary. You'll also notice that we don't have the alertness buttons, and if they go off, you will need to secure yourself from that. So use the time to practice, make sure you secure your rooms, check the hallways for other students. At the end of this training, in about 5 to 6 minutes, we're going to come in and make sure all the doors are secure. At the end of this, we will let you know that we're done. Thank you.
Kristen, can you, yeah, you can grab a seat or wherever if you want, or just leave. Can you hit the silver button on the right side so we don't just record for the next 5 to 6 minutes? Make sure that red light comes on. Sweet. Thanks, guys. I appreciate y'all making that as painless as possible. It was great. Right, Taylor? All right. So, guys, when I ask you to interpret, 1, go to the core meaning of that concept. 2, use the context. What's the context? The typical what? Height of 8-year-old girls in a large school district. That's my context. Right? Sorry I'm being lazy, but for the sake of time, I would actually write that though. What is the typical height of 8-year-old girls in this large school district? That is how you interpret. You get to the core meaning of the concept, and then you put the context with it. That's interpreting. And it's not just that one way. That is how I would probably write it in this case. There's plenty of other ways, as long as you talk about the typical or the average, you include the context and you indicate that it is 50 inches. So what about standard deviation? What do we mean by standard deviation? This is something we've got to remember. And it's not just how far the graph we're marking on the graph, because I saw a few of us talk about that. That's a procedural thing. What do we mean by standard deviation? Say again? How it strays from the mean, right? We talked about it. How far, on average, typically, how far does the data deviate or differ from the mean, right? So I would start with my context here. So if you're uncomfortable with the writing of it, cool. It's okay with like the wording gets awkward at times. You gotta have these core ideas. So the heights of, so I'm actually writing the context out here, being a little lazy here, but the heights of 8-year-old girls. Notice we need all those details, because is this for 16-year-old girls? No. Is it for 8-year-old boys? No. Is it for people outside of the school district? So we gotta have all of this. The heights of 8-year-old girls in the large school district. Typically what? Typical, right? Standard. Typically what? Say again? Say it louder.
2.5.
Well, what the height typically was is 50 inches, but it typically what? It's a standard deviation. So it typically, what did Jaden say? Strays from, or deviates from, right? It's a deviation. It differs from. So it typically differs from the, what does this mean again? What's that? This what? Population mean. It's mu, but it's population mean. So how much, Davian, does the height typically deviate or differ from that mean?
2.5.
By 2.5 inches. Notice I've got the context and I've got the core meaning of the standard deviation. That's how you interpret. I've got a context and I've got the core meaning of the standard deviation. Those are the things I'm going to be looking for. However it's worded, right? Typically, the height of 8-year-old girls in the large school district differ from the mean by this amount. 2.5 inches is how much the heights of 8-year-old girls in the school district typically differ from the mean. You can rearrange it as long as you are talking about the context and you are talking about the core meaning of a standard deviation. And so if that was something you were missing, not just writing the answer, but maybe writing those two ideas down might be something helpful to study by. In interpreting, what two things do you need? It starts with a C. Context. Guys, see, this is why we gotta write stuff down. You forget it 5 seconds later, right? You gotta have the context and the core meaning. I guess that starts with a C too. But the core meaning of the term. Context and core meaning of the term. Context and core meaning of the term. Got all that, Peyton? Sweet. Okay. Context and core meaning. That's for average and standard deviation. Excuse me. All right. A simple thing. Next, I ask you for the z-score of AVA, right? First off, I'm asking for a z-score. So what's something simple that you could write down to start? Literally, what are we calculating? So z-score, and how do we calculate a z-score? Value minus mean divided by standard deviation. I saw some of us putting 8 in here, right? But my mean is in what units? Inches. My standard deviation is in inches. The value needs to be in inches. I'm focused on the height, guys. So what's my value here? Good job, 53 inches. That's how tall she is. What's the mean? 50 divided by 2.5. Be careful. I saw a couple of us who type, I can tell, because I just know how calculators work, type this into the calculator without putting parentheses around this and got a really wacky z-score. Okay? If you didn't put parentheses around this, you ended up with 53 minus 20, which is 23. Guys, we're not getting z-scores in the 23s, right? Z-scores are typically between what two numbers? Not necessarily just 1 and 2. Think about your empirical rule. It's typically between -3 and 3. Somewhere in there. Okay? At least close to there. Notice if you follow the order of operations, you should have gotten 1.2. So be careful as you type these things into a calculator. Put parentheses if you need to. But also remember, right, Kyron, you know 53 minus 50, right? Yeah, that's 3. Guys, for simple things, don't stress yourself out putting it into a calculator. You know how to do 53 minus 50? All right. Questions about z-scores? By the way, have I shown clear evidence just by writing out the formula, substituting in, and simplifying that I understand how to calculate a z-score? Yeah. Sometimes you need to explain things, sometimes you just need to show work. Evidence. What is the reason that you're putting the answer that you did? So C, though, explain the meaning of the z-score. So we need to remember, guys, what a z-score means. Like, when I look at this 1.2, what is that 1.2 telling me? The z-score is how many what?
Standard deviations, the values from the mean.
How many standard deviations the values from the mean. That's why when we did our normal distribution earlier, which we're going to use this in a second, but in this case, what's my mean? 50, right? With what standard deviation? 2.5? So notice, I go to my point of inflection, that's where 52.5 is. I use that same distance over, that's 55 inches, and then 57.5. I go below, so I subtract. And it doesn't have to be perfect, but the closer you get to this, the easier it is to see things. But remember the mean. How many standard deviations is the mean from itself? That's why on the standard normal curve, what's in the center? 0. How many standard deviations is 52.5 from the mean? And why are these positive and these are negative? These are positive because they indicate
higher.
It's above the mean, right? These negatives indicate these values are below the mean. So don't forget, these are numbers of standard deviations. So when I see 1.2, that means Ava's score, or not Ava's score, because it's not a score, but Ava's what? Because notice I'm interpreting the meaning, so I need what two things? I'm explaining the meaning or interpreting, so I need context and core concept. What's the context? Ava's height is core concept. What's the standard deviation? It's the number of, or what's the z-score? It's the number of,
The number of standard deviations from the.
so her height is 1.2 what? Standard deviations. But I'm not just going to say from the mean, because from can mean either direction. It's 1.2 standard deviations above the mean. So again, these were some of the biggest issues I saw someone was having. That's why I'm taking a little bit more time here. So that's how many standard deviations her height is above the mean. Questions, comments, concerns? Now, remember percentile. By the way, everyone needs a calculator. One person per group, go grab calculators for everyone in the club. So in here, the kings can be just knocked off the sound of the pitbull. All right, remind me of this. Mary, when I want a percentile, what's the three words that I told y'all to remember? It's something or something.
At or above?
At or below. Peyton, percentile, it's what? At or below. Taylor, percentile. Crystalline, at or below, right? So, what is Ava's percentile for height? So, we already calculated her z-score, by the way. That could be really helpful in a second. So, I'm going to mark where she is, 53 inches, about 1.2. And so, I now need to shade this. So, Miles, where am I going to shade? Left, because I want what? At or below. So, I need all of this. And so what are we going to do to find all of that? I'm not going to make my life hard. Can I use empirical rule here?
Yeah.
A little bit? You sure about that? What do you have to have for an empirical rule? It's got to be normal, but you also need how many standard deviations? What type of standard deviations? It starts with an I. Integer. Remember, your integers are your whole numbers or their opposites. I need a 1, 2, 3 or a -1, -2, -3. Is that what I have here with this z-score? No. See, that's part of the reason why I want you to convert to z-scores, because that tells you right away, can you use the empirical rule? Can I use it? No. You got calculators though, right? Davis, what button lets me do cool crap on these calculators?
Menu?
Menu. Okay, so everybody hit menu. Let's make sure we know how to do this. And then where are you going to go? Statistics or probability. I don't care which one. Then distributions. Is that one not working, David? Here, set it off to the side so I can look at it. There you go. All right, so what type of distributions are we dealing with, by the way? Okay, so hold on to that. That's not a type of distribution. What type of distribution is this? That looks pretty normal to me, right?
I need inverse.
So, okay, hit inverse normal for me. Notice, what does it ask for there? It asks for the, do we have the area? Or do we have the bound? Oh, so do I want inverse normal? No, that's okay to make that say, hit escape, right? Go back through it. We don't want inverse normal, we want normal CDF. We have bounds and we want the area. So what would this lower bound be? You can use -5, you can use -10, technically it's negative infinity, but you can't put that into these calculators, right? I would probably do -10. What would my upper bound be? 1.2. Remember, I like to use my z-scores because that allows my mean to just be what? If I'm using z-scores, what's my mean? 0. What's my standard deviation? Right? I don't have to change anything if I'm using z-scores. So what's that area?
0.88.
Okay? So, now if you want stronger evidence of understanding, interpreting that percentile would be helpful, right? 88% of Ava's peers are at her height or lower, right? That's what a percentile is, at or below. But that's enough for clear evidence of understanding, even a CCC, clear, consistent, convincing. All of that drawing, the area, converting it to a percentile. What questions do you have? Is this helping fix the things we were struggling with? Yes? I know you still need some practice after this, right? So we may not get to the next unit today, we may start that after the test tomorrow. Trying to budget the test to only be an hour. An hour and a half's a long time. Alright. E, what changes in E? Am I looking for a percentile again? I'm looking for a percent this time. And so it's still a percent, it's just not a percentile, it's in between two values. What two values is it in between? So 46 and 53. Notice I actually was very intentional about this, where I gave you one of the values that you'd already used, because that means my upper bound has what z-score. And all I gotta do is convert that 46 to a z-score, right? I think if I remember correctly, that comes out to be a negative 1.6. Is that right? Is that right? Yeah. Okay. So then let's find our area. Come on, guys. Anybody got that area yet? 83%? Anybody need to push back on that or ask a question? Alright, we all accepting that? Okay, one thing I'm going to caution is make sure you pay attention to the language of what I asked. Because what did I ask for just now? So 0.83 was the area. And so 83% is what we eventually want to get to, right? The reason why I'm saying that though is that right in that area, converting that to a percent is really helpful. And then putting context to this. That's not a random number. 83% of what? 8-year-old girls in the school district are between 46 inches and 53 inches tall. Context, it matters, especially when we're dealing with real world stuff. One thing I want to point out and emphasize, what if I were to change the question to this? What is the likelihood of an 8-year-old girl in Ava's school district being 46 inches to 53 inches tall? Would that change our final answer? What would the final answer now be? Remember, this is a probability question, right? Probability of a single girl being between 46 inches tall and 53 inches tall is this, which is why because 83% of all 8-year-old girls are between that height. Questions? Yes, Taylor.
I got that answer, but I don't know how I got the answer.
Same.
Right.
Yeah. Let me see what I wrote. Yeah, that's why I put Y. I was like, I don't know how you got there. My guess is you used the normal CDF in the calculator with 56 or 46, 53. But that's what I was saying earlier. Like, if you don't write down how you got there, one, you can't use that to study later. Two, I have no way to know how you got there, right? Which is why if you just write the final answer, it's an LE plus, right? I don't know how. I don't have the evidence of how you got there. I need you to show me how you got there. And like, if you were to do this, would that be some clear evidence of how you got there? Making a note that in the calculator you use normal CDF with that lower bound and that upper bound, right? So adding that information is both good for me and for you. Okay. Questions? Bella, you good? Okay. Final one. A lot of us were actually really strong on number 4. But I do want to point out that we need a little bit stronger evidence for why we're putting what we are. Why is the mean 140 here? It's right in the center. That's all you had to say, guys. The mean is 140 because it's in the center. Some of us just said, hey, it's 10 because the standard deviation is 10 because it's how far we're counting. So like if I were to change it to this, would my standard deviation change to 5? Because I'm counting by 5s? Just because you change that scale doesn't change the standard deviation. Why is the standard deviation still 10? Thank you, right? I know my standard deviation is 10 because of the point of inflection, right? The point of inflection goes to 150, and how far is the mean, or how far is 150 from the mean? It is 10, right? Like, we have to remember the standard deviation is based on that point of inflection and nothing else. And so I'll actually update that question in the future, because I wanted to make sure that we are clear that we understand the standard deviation is what tells us, or the point of inflection tells us where the first standard deviation is. Does that extra detail make sense? Okay. All right. Quick show of hands. Who? Oh no, there's one thing I need to talk about. All right. This isn't as big of an issue for y'all, so I'm not going to sweat this. It's more for my third, fourth block. Do not forget, what are the 3 types of studies? Sample survey, right? Observational, experiment, sample survey. Know the differences between them. Population, what keyword should you always use with population? All, right? Notice the 1,500 US teens is not my population. So based on, this is the second demonstrated understanding on study design. What was the 1,500? That was the sample, because that's where we got our data from, right? Use that justification. You know I'm asking for population sample characteristic of interest. It's an easy thing to say. 1,500 is where my data came from. That's my sample. And if that's my sample, the population is not 1,500 US teens, but all US teens, right? Most of us recognize that this was an experiment. What are the 2 key features of an experiment? We're looking for what inference? Cause and effect, and we have to have treatments. The researchers told the teens to do these things, right? They did not change their habits, or they drank 2 cups, and they drank 2 cups and spent an hour in full spectrum light. All right, so think through those details. Justifying here, I got a lot of us that came up with questions, but if we had taken a second to remind ourselves, responses need to vary. And categorical means the responses need to be a what? What do responses fit into? Categories. Right, if you need to, maybe go take a picture of the Post-its, right, that y'all created. And look at some of the categorical pieces of data that y'all collected. But we're also not looking for a survey question. We could ask the question of what is the most common hair color? Or add more clarity, what is the most common hair color at Hillcrest High School? The responses would be the hair color. What is the favorite sport of Hillcrest High School students? What's the favorite sport of students in Tuscaloosa, right? Add clarity, make sure your responses are categories. This is the main one I wanted to focus on though. Is the last thing we'll talk about here. What are the types of sampling techniques? There were 4 of them. And I think I wrote on most of ours and missed this. What? Random. Subjective. Volunteer. That was a type of study, remember? It's easy. Convenience. Okay? And I'll update this question, I think, in the future. But if they can complete it on their own, then they are volunteering, guys. If they can complete it on their own, they choose whether they complete it. If you select, you make a choice, you make a judgment that is subjective. Asking the first 100 people, not really random. It is convenient, isn't it? It's super easy to just talk to the first 100 walking through the gates. Notice I'm identifying key things, like there's not a whole lot necessary to this, but is that going to be evidence for why I'm picking these answers? Yes. Key detail in D. Random number generator, so it's random. These are the things we want to pay attention to. That's justification. Which of these techniques would be biased? What's got to be there for it to not be biased? Say again. Has to be random, right? Volunteer, subjective, and convenience. Those are all bias samples. This one is not. And then remember, when you pick one to explain how that sample may be different from the population, you can't just say, oh, they could be different. Asking the first 100 people to Coleman Coliseum if they think the team deserves a new arena. Guys, if they're the first 100 to the Coliseum, they probably really like men's basketball, right? So are they more or less likely to think that they need a new stadium? More likely, right, for a Coliseum. If you select 20 people you think might represent the typical GPA at Hillcrest High School, you're going to pick people that you know. And are your friends necessarily representative of everyone at Hillcrest High School? No, you generally have your friends that you hang out with. You need a mix of people from honors and AP classes, advanced classes, and regular classes, but you probably stick with people in one of those groups. So you selecting, still biased. We did an exact one like A in class. If they can choose to do it on their own, it's more than likely that people who are not playing sports, who are not doing after school curricular activities. So we want to keep that in mind. Sorry, there's a lot of information done, but I hope all of this helps us understand these details more. But again, do not forget, when we talk about bias, you need to tell me how could that sample not represent the population? Those first 100 people are different from the rest of the population because they are the most diehard fans, so they probably think that the team needs a new Coliseum, probably at a higher rate than the normal population. How is that sample different? Questions, comments, concerns? Yes, ma'am. Say again. Okay, I'll come look at it while we're working in a second. here's a question I have for you. Do you feel like you need to, is there anyone here who wants to work on and study design? Or do we feel like we need to work on normal distribution stuff? Anyone who wants to work on study design, studying that for the test? So we're all in normal distribution? That's what I figured. So to help us with that, what I want you to do is I want you to turn to lesson 4 in your textbook. By the way, leave your demonstrated understandings out so I can quickly make scans while y'all work on this. Oh, by the way, guys, sorry, I meant to mention this earlier. Guys, confounds. When we were talking about classical music and math test or student anxiety, what are the only 2 things I care about? If listening to classical music affects student anxiety. But what else can affect or relate to student anxiety? I literally told them to you. Differences, what can make a difference in student anxiety on the test? This is from the back side of your second demonstrate your understanding. The teacher, your history in your math classes, and amount of time study, right? Like those could affect your anxiety during a test, correct? But what's the only thing I care about? The classical music. So confounds, right? They could be a problem because is it the classical music or is it these things that's affecting the anxiety? And so we haven't gone into how to reduce the effects of confounding. That's what you'll do in an AP stats class if you ever take that, or just stats in general. But we need to be aware that it can mess up my understanding about what was the inference for an experiment. Cause and effect. If I ask you about cause and effect, it has to be a what? If I ask you if the study can establish cause and effect, it has to be an experiment. Was this an experiment? Yes. I'm not guaranteeing that it will be on your test, but notice if I ask you, hey, can this establish cause and effect? It's got to be an experiment. We had treatments. This was an experiment. Can it establish cause and effect? Yes. If we reduce the confounding. And I know a lot of people are like, well, there's a lot of confounds here. Yes, there are possible ones, but we can address those. Sorry. So chapter 4 from our textbook, or lesson 4 from our textbook. So this is all about normal distributions. This one's actually focusing on probability. And so I want you to turn to 4.1. I don't have no clue what page this is. Maybe page 40, 50, I don't know. 47. Look at that. I was close-ish. All right. So we are collecting data on the delivery times for 2 local pizza shops, Antonio's Pizza and Wood-Fired Pizza. Based on your data, Antonio's Pizza has a mean delivery time of what? 30 minutes and a standard deviation of? 3 minutes. Wood-Fired has a mean delivery time of? 25 with a standard deviation of? 8. Okay? I'm not going to worry about number 1 because I need us to really just focus on 3, I guess. Like in general, which of these pizza places would you get your pizza from? Wood-Fired? You think so? So it depends, right? Like we need to make data-informed decisions. So let's actually talk about number 2 after you work on number 3. So today, right now, it's time for you to study and focus. So I would encourage you to work together. But you can do this individually, or you can do this together on vertical surfaces, together at your desk. Do what you need to do. I'm going to collect your demonstrated understandings, make scans of those to make sure I have those. Questions? And go. Oh, you can always work on the vertical surfaces. In fact, I encourage it.